as I was telling you, I could use a string like red to mean the color red, or a string like car1 to mean that that's my car. So representation is a relationship between two domains. The first is meant to stand for or take the place of the second. In the example that I was illustrating, red is standing for the red color. Usually the first domain, the representer, is more concrete, immediate, or accessible in some way than the second. It's like you are driving on a highway and you see on a signpost a hamburger. Now immediately you would know that some fast food restaurant is nearby. So here is the hamburger representing the fast food restaurant. The type of representer that we will be most concerned with here would be formal symbols. So these are character or group of characters taken from some predetermined alphabet. Like for example, the digit 7 stands for the number 7, as does the group letters V11. Now what is knowledge representation then? To answer this question, what is knowledge representation? The best reference that we can think of is the paper by Davish, Schroep and his colleague on what is knowledge representation. According to them, a knowledge representation has the role of a surrogate. That is, I should look at the representation as a surrogate of what is being represented, and it would be a set of ontological commitments that I make. Now one needs to remember at this point that a knowledge representation is not a data structure. It is a set of ontological commitments about what is there that I am representing. The third role of knowledge representation is that of a fragmentary theory of intelligent reasoning. Now this brings us to the question of what is intelligent reasoning. Intelligent reasoning, I could take the logical view as well as the psychological view, but then here we keep ourselves restricted to the logical view, and we will look at which inferences are sanctioned, which inferences are recommended. The fourth role of knowledge representation is as a medium for efficient computation. And then they have listed the fifth and the final role of knowledge representation as a medium of human expression. We will look at each of them one by one in the next couple of slides. So let us look at what we mean by knowledge representation as a surrogate. When we say knowledge representation is a surrogate, we mean it is a substitute for the thing itself. So it is used to enable an entity to determine consequences by reasoning about the world. Next, it is a set of ontological commitments. That means having a knowledge representation, I am now able to answer a question like, in what terms should I think about the world? Now this is one important aspect that we need to understand, that ontology means the world as we see it. So in what terms should I think about the world? The knowledge representation gives me an answer to that question. As a fragmentary theory of intelligent reasoning, it could be expressed in three components. One, the representation's fundamental conception of intelligent reasoning. Two, the set of inferences the representation sanctions. And three, the set of inferences it recommends. Finally, knowledge representation is a medium for pragmatically efficient computation. That is, it provides a computational environment in which reasoning is accomplished. Now, one contribution to this pragmatic efficiency is supplied by the guidance a representation provides for organizing information. So a representation allows you to organize information in the most efficient way so as to be able to make the recommended inferences from it. It's a medium of human expression, that is, it is a form of language in which we see or say things about the world. So knowledge representation, as I have been emphasizing from the beginning, is an important sub-area of artificial intelligence, which is concerned with understanding, designing, implementing ways of representing information in computer so that programs or particularly intelligent agents can use this information. Now that information would be used to derive new information, to converse with people in natural languages, to decide what to do next, that is to take decisions, to plan future activities, and to solve problems in areas that normally require human expertise. Let us now focus on what we mean by reasoning. Now, having said that representation is about getting to some symbols, reasoning is the use of these symbolic representations of some statements in order to derive new ones from them. One must realize that statements are abstract objects. Their representations are the concrete objects that we have created and we can easily manipulate. Knowledge representation schemes would be useless without the ability to reason with them, and that is why we say knowledge representation and reasoning together. We do not only look at the representation part. Reasoning is an integral part of knowledge representation, and that is why the term is knowledge representation and reasoning. Now, how does knowledge representation and reasoning work? One realization that one needs to have even before you start working with knowledge representation and reasoning is that any form of intelligence requires knowledge, and computational models of intelligence requires models of knowledge on which to work on to get or infer new knowledge. Use formalisms to write down knowledge, and then these formalisms must be expressive enough to capture human knowledge. They must be precise enough to be understood by machines. So this is something that I would love to emphasize one more time, that when we are trying to use formalisms to write down the knowledge for a given problem, we would definitely want them to be expressive so as we can capture as much human knowledge as possible. But then it needs to be precise as well to be understood by the machines. Separate knowledge from computational mechanisms that process it is very, very important. We need to understand that the knowledge and the computational mechanisms that process it need to be separated, and that is why I emphasized in the beginning that knowledge representation is not about having a data structure. So there is an important part of cognitive model in what the organism knows, but then we should not mix both the knowledge and the computational mechanism of a system when we are trying to create an intelligent system with a knowledge representation reasoning. So the next question arises is, how can knowledge be represented? Now in the very beginning I had pointed out that there are two approaches to AI. One, the symbolic AI, which is about creating intelligence through manipulation of symbols. The other approach is the connectionist AI, which is about creating the computational model of the human brain. Depending on which approach you take, you could have symbolic methods of representing knowledge, which would involve things like declarative languages, imperative languages, hybrid languages like Prolog, rules, frames, semantic networks, so on and so forth. We could have non-symbolic methods of knowledge representation, the popular among them being neural networks and genetic algorithms. Now, let us quickly focus on what we mean by knowledge representation languages. Now, rather than general purpose languages like C++, Java, knowledge representation requires use of special purpose formalisms. A knowledge representation language should allow one to represent adequately the knowledge you need for the problem, two, do it in clear, precise and natural way, three, allow you to reason on that knowledge, drawing new conclusions. We will look at each of them one by one.